Okay, so this is 1333 here, and we're given these two blocks sitting on top of each other, and we're given this angle theta here. Between the two blocks, we have a coefficient of static friction, which is mu sub s, and then we're supposed to neglect friction between A and the bottom here. And what we're trying to find is the largest horizontal force, P, which can be applied to B here, so it will not slide on A, and then also the corresponding acceleration with that. So let's begin our analysis. And to begin our analysis, I'm just going to draw a free body diagram of that top block here, this block B. So let's draw that block B here. Okay, so we have a horizontal force P there. We have downward, we're going to have our mg here, m times g. We're given that both blocks, I forgot to mention that, both blocks have the same mass. So ma equals mb, which we're just going to call m. Okay, so downward force of mg, and then we're going to have a normal force here, and we're going to call that normal force AB. And then the frictional force is going to be this direction, and that is mu sub s times NAB. And remember, we have this angle here is theta, so from horizontal here, this angle is theta. Okay. So let's get started. We can sum the forces in the y direction and set those equal to 0, right? Because we know that this is not accelerating in the y direction. We're figuring this out so when A does not slide on B or vice versa. So we know that the acceleration in the y direction is 0. So the equations we have NAB, a component of this upwards. So we have NAB, and that is cosine of theta, component upward here, since this would also be theta here. So we have cosine theta upwards. And we have mg downwards here. And then we also need to take into account this frictional, the y component of this frictional force here. And that will be negative mu sub s times NAB, and that will be sine of theta here. And all of that is equal to 0. And let's rearrange this equation for NAB. So rearranging this equation, we have NAB comes out to be, move the mg to the other side. We should have this being mg divided by cosine theta minus mu sub s sine theta, because both this one and this one, these two elements have NB associated with it, so those should be on the bottom there. So all right, so we have NAB here. And now let's take the sum of the forces in the x direction. And the sum of the forces in the x direction will be equal to the mass times the acceleration in the x direction. So doing that, we have P acting in the negative x direction, so that's negative P. And then the normal force here will be acting, the component of it will be acting in the positive x direction, NAB, and that should be sine theta. And then we have the frictional force also acting, and the component of the frictional force should be acting in the positive direction as well. NAB, and that should be cosine of theta. And then all of that is equal to mass times the acceleration in the x direction. Okay. So let's factor NAB out of these two things here. So this one and this one both have NAB associated with it. So we have negative P, and that will be plus NAB, and then we have sine theta plus cosine theta equals mass times the acceleration in the x direction. And now let's take what we found for NAB up here and plug that in down here. So let's do that. So we have negative P plus mg over cosine theta minus mu sub s sine theta. So that's NAB, and then that will be multiplied by sine theta plus cosine theta equals MAX. All right, it's getting a little messy here. So let's straighten this up a little bit, and I'm going to put these two things out front here. So I'm going to pull mg out front, and that's going to be sine theta plus cosine theta divided by cosine theta minus mu sub s sine theta, and that's minus p equals m times ax. Oh, okay. All right, so I'm going to leave it like that here. And so how do we figure this out? Well, just by analyzing this one free body diagram, we can't really do it. Let's take the whole thing, the whole outline of this here, and let's analyze that as a free body diagram. So I'm going to draw the two blocks together, and then we have P on top here, and then we have, if we combine the two blocks downward here, we have 2mg downward, and then we just have a normal force here. Remember, we're told to neglect friction between the bottom surface and the bottom block here, so there's no frictional force here. So let's analyze this whole structure of these two blocks together, and the sum of the forces in the x direction should equal the mass times the acceleration in the x direction. All right, so in the x direction, we have our regular coordinate system x, y. We have negative p here, and that is equal to the mass, all right? And the mass here of these two blocks together is 2m, and that's multiplied times the acceleration in the x direction. Okay, so rearranging this equation, we have P is equal to negative 2 MAX. Yeah. Now we can put this value that we just found back into this equation here, and we should be able to solve for AX if we put this back into the equation. So putting that back into the equation, we get, and solving for AX, we have AX is equal to negative sine of theta plus mu sub s cosine theta divided by cosine theta minus mu sub s sine theta times g. Okay, so this big messy thing here, that's ax, and putting ax back into this equation, we can solve for p, which is 2mg, and then this whole messy thing, sine theta plus mu sub s cosine theta divided by cosine theta minus mu sub s sine theta. All right, so those are our two answers for this problem.